Hello, this is Jack Jackson. We're going to continue our look at classification of quadrilaterals. In the last video, we looked at the number and position of congruent sides as a way to classify them. This time, we're going to look at the number of parallel sides. Of course, the parallel sides will be opposite. Of course, we could have one that doesn't have any parallel sides. That would be a non-trapezoid, but if it has a pair of parallel sides, we call that a trapezoid. And so here's a trapezoid here. There's not a lot of properties of a trapezoid, but there are a few. In addition to having a pair of parallel sides, when you look at the angles, it has two pair of supplementary angles that are consecutive. So this pair of angles that are consecutive but not a base pair have to be supplementary. If you add that one up with that, uh, you'll get um, pi, okay, or 180 degrees. Same way if you add these two over here. Okay, and that follows from the C property of parallel lines cut by transversal. Okay, so notice that a trapezoid is at least one parallel side, so that includes, we can manipulate this at some point where it becomes a parallelogram, includes isosceles trapezoids, right trapezoids, and some other kinds of trapezoids. Okay, but all these are trapezoids. So if this side is horizontal, which doesn't have to be, then this side is horizontal. Notice both of these could have like negative slopes, both could have positive slopes. One could be vertical, one could have a positive slope, one a negative slope. So that's trapezoids. Now we got some special kinds of trapezoids. One is a right trapezoid. That's a trapezoid with at least one right angle. And one of the properties we see is that it's going to have at least one other right angle as well. In fact, it'll either have exactly two, or somewhere in here, there's exactly four, where it's a rectangle, or it'll be like this, where we have a right trapezoid. We'll have an isosceles trapezoid. An isosceles trapezoid, by definition, has a pair of congruent base angles. So see the last playlist for some exploration of this. But here's some extra stuff that you can construct here. For one thing, it has a line of symmetry about the midpoints of the two bases. If you draw a line segment here that's parallel to this other side, notice that all three of these are the same length, which is going to help us to prove that this is that the legs are congruent. The midline is connecting the two um, midpoints of the two legs. It actually always turns out to be a cyclic quadrilateral, so there's always a circle that can go around and connect to the to all four of the vertices. If you look at the two diagonals, you notice that they are the same length. They are congruent. This includes a rectangle. I have this one set up in such a way that CD is always the longest side. It may be the same as the other side, in which case it's a rectangle, same length, or it may be longer, like this. We have four little triangles here. The two that contain the legs are congruent. So triangle AXD is congruent to triangle BXD. And then these two are not congruent necessarily, but they are similar. So triangle AXB is similar to triangle DXC, and those two are isosceles triangles. So these other two are congruent, but not necessarily isosceles. These two are isosceles, but not necessarily congruent. They are, however, similar. Okay, and here are some properties of the isosceles trapezoid, which we studied earlier. A Sakari quadrilateral is a quadrilateral with a pair of right base angles. Well, in Euclidean geometry, that's just a rectangle. So a Sakari quadrilateral is more of interest in non-Euclidean geometry. If you have two pair of parallel sides, then you have a parallelogram. So we did one pair of parallel sides and then two. One pair of parallel sides is a trapezoid, and we looked at various subclasses of trapezoids, right trapezoids, isosceles trapezoids, and parallelograms. And we've studied this one in the previous video in this playlist, gone over its properties as well as really hitting us hard in the last playlist. So I'm going to move on to the end of this video, and the next one we'll pick up looking at the classifying by number of position of congruent angles.